When we think about limits to knowledge, we usually think in practical terms. We assume we lack better instruments, more data, or enough time to observe. But some limits exist even in a universe with perfect technology and perfect observers. These limits are not about capability. They are built into space-time itself. These limits are created by horizons. A horizon is not a physical object or a wall in space. It is a boundary created by the structure of space-time that limits which events can ever influence one another. Beyond a horizon, things may still exist and happen, but they are causally disconnected from us. No signal from there can ever reach here, no matter how long we wait or how sensitive our instruments become. This means some information is not merely unknown, it is fundamentally unknowable. In cosmology, the most familiar example is the cosmic horizon. The universe has a finite age and is expanding, which means light from distant regions has not had enough time to reach us. There are galaxies whose light is only arriving now, and others whose light will never arrive at all. As space expands, some regions move away from us faster than light can cross the expanding distance between us and them. When that happens, those regions pass beyond our horizon permanently. Any information they contain is lost to us forever, not because it was destroyed, but because it can no longer be causally connected to us. No future observation can change that. This is not a failure of telescopes or patience. It is a geometric fact about space-time. Even if we waited infinitely long, signals from beyond certain horizons would still never arrive. The universe does not allow complete access to itself from within. It does not provide a global point of view. Horizons appear at smaller scales as well. A black hole has an event horizon that separates what can still affect the outside universe from what cannot. Once matter or information crosses that boundary, it cannot send signals back out. From the perspective of an external observer, whatever crossed the horizon is no longer accessible in any operational sense. Whether that information is preserved internally or transformed is a separate question. What matters here is that access has ended. From the outside, the information no longer participates in cause and effect relationships. But horizons do not require extreme objects like black holes. Any system has effective horizons defined by how fast information can propagate and how quickly the system evolves. In chaotic systems, information spreads so rapidly and non-linearly that it becomes effectively inaccessible, even without a sharp boundary. In practice, this creates information cutoffs that behave like horizons. This leads to an important realization. All knowledge is local. Observers never access the universe all at once. They access it through signals that arrive within causal limits. Everything we know comes through light cones, interaction speeds, and finite durations. There is no viewpoint outside the universe from which everything can be observed simultaneously. This is why the idea that the universe could be fully reconstructed from within itself is flawed. Every observer is embedded in the system they observe. Every measurement is constrained by where and when it occurs. Horizons don't just limit what we can see, they limit what questions are physically meaningful. If information cannot reach us, it cannot influence us, and if it cannot influence us, then from a physical standpoint, it does not belong to our universe of causes. Physics concerns itself with what can affect outcomes, not with what exists abstractly beyond reach. This does not mean reality stops at the horizon. It means physics stops making claims beyond it. That restraint is not weakness, it is precision. Horizons enforce humility. They remind us that completeness is not guaranteed. The universe does not promise transparency, it promises consistency within limits. These limits also matter for memory. Even if information is preserved somewhere beyond a horizon, it cannot participate in local records, correlations, or future evolution on our side of the boundary. Memory requires access. Without access, information may as well not exist for anything that follows. In this way, horizons are not only spatial boundaries, they are epistemic boundaries. They define what can be known, tested, remembered, and correlated. As the universe expands, horizons evolve. Information that was once accessible can become inaccessible. What we can know today is not necessarily what we will be able to know forever. Knowledge itself changes under constraint. The universe does not guarantee that everything that happens will be observable. It only guarantees that what is observable will obey consistent laws. Understanding horizons helps us avoid false expectations. The expectation that physics should explain everything everywhere. Instead, it teaches a quieter lesson. Physics explains what can be connected. Beyond that boundary, silence is not ignorance. It is structure. My name is Charles Carroll. Thanks for taking the time to listen.